This tutorial video is solutions to the GCSE revision questions on transformations. You need to be familiar with what transformations are, you need to be familiar with reflections, rotations, enlargements and translations before beginning these questions. Question number 1. Describe fully the single transformation which maps triangle A onto triangle B. First thing to do is you're starting from A going to B, so check where your starting point is. The triangle has turned round as it's moved from A to B, therefore we're dealing with a rotation. Notice 3 marks, you're only going to get 1 mark for writing rotation. You need to describe the rotation. You need to describe which direction the shape has turned, how many degrees, and you need to also give the centre of rotation. Shape's gone from kind of like that to like that, so we've got a 90-degree rotation. The direction of rotation is that way, which is clockwise. And finally, for the centre of rotation, you need to get yourself a piece of tracing paper. Get your hand up in the exam hall if you don't have some. Get the invigilator to bring you one over. Tracing paper over the shape. Trace the shape you start with. Pick any point on the grid, put your pencil on it, and rotate your piece of tracing paper 90 degrees clockwise. Does the triangle fit over the top of B? No, it doesn't, so that's not the centre of rotation. Try again and keep trying until you get the point. With a bit of practice you'll be able to spot it quicker. The centre of rotation is at the coordinate 1, 1. So we need to write centre 1, 1. Question number 2. Describe fully the single transformation that maps P onto Q. So again, starting with this one, ending up at that one. Shape Q is bigger than P, therefore this is an enlargement. Again, there are 3 marks available for this question, so we need to describe it. We need to say how many times bigger the shape is. Well, if we look at this edge, it's 2 squares long, and this corresponding edge on the enlarged shape is 5 squares long. So what has 2 been multiplied by to turn it into 5? If we do 5 divided by 2, get the answer to that is 2.5. Q is 2.5 times bigger than P, therefore the scale factor is 2.5, and we need to give the centre of enlargement. Way to do that is to take corresponding points on the original and the enlarged shape and join them up with projection lines. If you do that for all 3 corners of the triangle, then all of those lines will cross in one place. That point is the centre of enlargement, which in this case is coordinates 0, 0. Question number 3. Shape P is reflected in the line x equals -1 to give shape Q, and then Q is reflected, and then we have to describe the transformation. Let's go through the first one. We have to identify the mirror line given its equation. Where is the line x equals -1? If you find some coordinate points where the x coordinate is -1 and you mark a few on, they should make a straight line. Once you've got enough points to be able to see where the straight line is, draw it in. There's your mirror line. Then shape P reflected in this line, 1 corner at a time. The distance from this corner to the mirror line is 2, so go 2 squares in the opposite direction. Likewise 2 squares, and so on. From here to the mirror line is 5 squares, so go 5 squares in the opposite direction and build up a picture of what the shape looks like. And that is shape Q. Shape Q is reflected in the line y equals 0, so again we have to identify the mirror line in the same way as we identified where x equals -1 was. The x-axis is the line y equals 0, so we reflect Q in this mirror line. Same method, 1 square to the mirror line, so go 1 square in the other direction. Repeat it for all the other corners. Build up a picture of what the shape looks like, and there is shape R. Finally, describe the single transformation which takes shape P onto shape R. How do we get from this one to this one? Well, this is a rotation. It's a rotation 180 degrees. When it's 180 degrees, it doesn't matter whether it's clockwise or anti-clockwise. 180 degrees is half a turn. It doesn't matter if you go left or right, you're always going to end up at the same place. What you need to do, as in question number 1, get your tracing paper on, trace over P, try different points until you get the right one. The centre of rotation is that point there, which has coordinates -1, -1, comma 0. Rotation 180 degrees, centre -1, comma 0. Question number 4. Describe the transformation which maps P onto Q. Important in this question that we get that right. Starting with the left shape, moving to the right shape. The shape has not been flipped over, it's not changed side, it's not been turned round, so by process of elimination this must be a translation. To describe a translation, we need to give a vector. A vector describes horizontal movement and vertical movement, where a positive number here is a movement to the right and a negative number is a movement to the left, and where a positive number here describes a movement up and a negative number describes a movement down. So go back to the two shapes, pick corresponding points on the original and the translated shape and count how far along you've gone and how far down. 1, 2, 3, 4, 5, 6 squares to the right, 1 square down, therefore the vector is 6 minus 1. Question number 5. On the grid, enlarge the shape with a scale factor 3 using the centre of enlargement. You could draw projection lines on, measure the distance from the corner to the point and then treble it. I prefer counting the distance in a horizontal and vertical direction and then trebling that. So, for example, from the centre to this corner is 2 units to the right and 1 unit up. Times those both by the scale factor of 3 becomes 6 units to the right and 3 units up. So from the centre of enlargement, go 6 to the right, 3 up. This point is moved to there. Same thing from here to here. 2 to the right, 3 up, becomes 6 to the right up, 6 to the right and 9 up. And then 5 to the right and 1 up becomes 15 to the right and 3 up. 15. Join up your points. And then to check you've got it right, this height was 2, check that this is 3 times bigger. Likewise, the base of this triangle was 3, check that this is 3 times bigger. Correct. Question number 6. Rotate triangle A 90 degrees clockwise. We're going 90 degrees, which is a quarter of a turn. We're going clockwise, which is this direction. Get our tracing paper on. Trace over the shape A. We put our pencil on the centre of enlargement, in the centre of rotation, which is the origin. We turn our tracing paper a quarter of a turn clockwise, and we have to transmit that triangle onto that exact position on the grid. Which is there. Part B. Enlarge the triangle, scale factor 3, centre 1, 2, centres marked for you. The method is exactly the same as in the previous question. From here to here is 2 squares along, 0 squares up. Scaling that up by a factor of 3 becomes 6 squares along. From here to here is 2 along, 3 up. That becomes 6 along and 9 up. And then from here to here is 4 along, 0 up, which becomes 12 along, 0 up. Again, check that the sides of your enlarged shape are 3 times bigger than the sides of your original shape. Base of 2, base of 6, height of 3, height of 9. And finally, question number 7. We have to perform a reflection in the line y equals x. Y equals x is marked on for us. You can see it's a diagonal mirror line. Easiest way to deal with these: spin your page round so that the mirror line is either horizontal or vertical in front of you. Now, take one corner at a time. The distance from the corner of the triangle to the mirror line is half a square, so go half a square in the other direction. From this corner to the mirror line is 1.5 squares, so go 1.5 in the other direction. This final corner is 2 squares from the mirror line, so go 2 squares in the other direction. Join your points up. There's your triangle. And finally, part B. Describe the single transformation which takes you from A onto B. So this time we start with this one and we're moving down to this one. It's not turned round, it's not flipped over, it's not changed size, so therefore it's a translation. We need a vector. Pick corresponding points. We've gone 2 left and 4 down, so the vector is -2, -4. Remember, positive would be right, negative is left. Positive would be up, negative is down. Exactly the same as on your axes. Positive right, negative left, positive up, negative down.